Good afternoon, everyone. Again, my name is Brad Walter, and today we're going to be discussing the topic of density altitude. And for today, I'm going to be simulating that I have a student sitting next to me that I'm teaching this lecture to. And that being said, we'll get right into it. Our objectives for this lesson are we're going to define density altitude and then talk about how it relates to our aircraft and what effect it has on our aircraft's performance. And then we'll use the formulas to determine how to calculate what our density altitude is. Alright, for our definition of density altitude, I pulled these from a couple of the handbooks. It's pressure altitude corrected for non-standard temperature. Another way to word that is when conditions are standard, pressure altitude and density altitude are the same. So if you have a standard day, it's at 15 degrees Celsius and 29.92 for your barometric pressure. If that's the case, then your pressure altitude and your density altitude are going to be the same. And your aircraft performance is based off of your density altitude. However high your density altitude is, that's how your aircraft is going to perform based off that altitude, not necessarily your field elevation. As you can see here, density altitude has a big effect on a lot of different areas of performance for our aircraft. So our engine performance is going to be reduced as our density altitude gets higher. So the air molecules are spread out more. So it's essentially taking on less air per the amount that's going in. And that's for non-turbocharged engines. So for turbochargers, the turbo compensates for that decrease in, or for the air molecules being spread out, and it recompacts them. But for a non-turbocharged engine, the air is spread out more, so you have less performance from your engine due to less airflow. Your prop efficiency is also reduced due to the thinner air, so there's less air molecules for that prop to grab a hold of and pull you through the air. And then also the same applies to lift. So you have less air molecules flowing around that airfoil to produce your lift. And so higher density altitude, less efficient engine, less efficient prop, and reduced lift. All right, so this is the items that are going to affect your density altitude, whether it's high or low. All of these combined make up your density altitude. So your barometric pressure, your altitude, your humidity, and your temperature. So if we go back to that definition at the beginning, it's pressure altitude corrected for non-standard temperature. So you take those first three, the barometric pressure, the altimeter, or the altitude and the humidity, that gives you your pressure altitude, and then you have your temperature at the bottom. So pressure altitude is those three combined, corrected for non-standard temperature, will give you your density altitude. And here in a moment we'll show you exactly how to calculate both pressure altitude and density altitude given simple information off of ATIS. Alright, so to do the calculation for density altitude, first we need to calculate our pressure altitude so we can then correct it for our non-standard temperature. To calculate pressure altitude, we're going to use an example today that we have a field elevation of 500 feet and a low pressure system in the area, so we got an altimeter setting of 29.82. So we take 29.92, subtract 29.82, and we get 0.1. We're going to multiply that by 1,000 times 1,000, and we get 100. So we take our 100 and add it to our field elevation to give us a pressure altitude of 600 feet. So our pressure altitude 600 feet. Next we're going to take our outside air temperature and subtract it from the standard temperature. So we're going to say it's a pretty warm day here in Florida. We'll say it's 25 degrees. And we'll subtract a standard day, which is 15 degrees Celsius from that, which gives us 10. We're going to multiply that by 120. It gives us 1,200. So 1,200 plus our field elevation, or our pressure altitude of 600 feet, gives us 1,800 feet. So even though our field elevation is only 500 feet, our density altitude is 1,800 feet. So So 1,800 feet is how your aircraft is going to perform. That's what all your performance should be based off of when you're on the runway, is based off of 1,800 feet and not that 500 feet, which is a pretty significant difference when you're talking about performance of the engine and then performance of your airfoils and prop. All right, in conclusion, we determined that density altitude can be very different than your field elevation, and that's why it's important to run that, and especially because your aircraft performance is based off your density altitude. So it's not going to perform like you're at 500 feet if your density altitude is at 1,800 feet, like we showed in our example. So it's very important to know your density altitude for pre-flight and during flight. That way you know what you can base your aircraft's performance off of. And these are the references that I used to put together this PowerPoint. Hope you enjoyed. Thanks.